CROCODILE back with another video. Today we are going to be solving some difficult permutation and combination questions since tomorrow it's your exam. Inshallah, I'm pretty sure if you guys will do pretty well. So today we're going to solve some difficult past papers. So the first difficult question that we have is actually pretty common for students, right? This question really does struggle. It's the crocodile question, the infamous crocodile question, right? So let's just start. So find a number of different arrangements of the 9 letters in the word crocodile. So this one's very simple. I'm pretty sure everyone can solve it. There's 9 letters, so 9 factorial divided by their 2 O's. So divided by 2 factorial. And then there's also 2 C's. So to divide by 2 factorial again. And we're gonna get 90720, which is your final answer. Very simple, right? Now moving on, the number B is find the number of different arrangements of the 9 letters in the word crocodile in which there is a C at each end and the 2 O's are together. So let's just first write 9 letters. 1, 2, 4, 5, 6, 7, 8, 9. Right. So there is a C at each end. So here's a C and there's a C, and the 2 O's are not together. So first I'm going to find the number of arrangements in which the 2 O's are together, and then I'm going to subtract it from the total. And the total is basically this, that you first arrange the 2 C's at the end, and then you find the arrangements. That's the total. So how many spaces are left? There is 7 spaces left, hence 7 factorial, but there are still 2 O's that are same since we're not considering it now. So this is the total, right? This is a total number of ways this can be arranged without the second condition, right? So this leads to 2520, and now we're gonna add the condition again. 2, 3, 4, 5, 6, 7, 8, 9. So the 2 C's on opposite ends and the 2 O's are together, right? So the 2 O's are together. So in this case, since we're going to consider this as one unit, this is 1, 2, 3, 4, 5, 6. There's 6 different ways this set of O's can be put together. Hence there's going to be 6 factorial. And it's just gonna be 6 factorial because the 2 C's are already arranged and the O's are also there. So it's just gonna be 6 factorial is 720. Now you subtract from this 2520 from 720. We get 1800, right? Very simple, guys. That is your answer. Now, moving on to number C. 4 letters are selected from the 9 letters in crocodile. So let me just write crocodile here real quick. Four letters. So 1, 2, 3, 4. Okay, find the number of selections. Selections, guys. Selections. Hence this is selections. It's gonna be combination, not permutation, because arrangement doesn't matter here. Find a number of selections in which the number of C's is not the same as number of O's. Okay. It's not the same. So how many so what can be the combinations? So let's say there is 1 C and no O's, or it can be multiple scenarios and we have to add all the scenarios up. So the second scenario can be that there are 2 C's, right? There are 2 C's but no O's. Or there can be 2 C's and 1 O. Still not the same number. The number of letters, 2 C's and 1 O. Or there can be just be 1 O and no C's. Or there can be 2 O's and no C's. Or there can be 2 O's and 1 C. These are all the ways this can be arranged. So after you arrange this, you're gonna eliminate the letters that are already here. So the C is already here. Okay, so you're gonna eliminate C. O is also here, so eliminate O. So how many letters are left? There, it can be R, D, I, L, E. 5 letters. So out of 5 letters, you're choosing 3, right? Hence, it's gonna be 5, C3, since there's three gaps. And over here same, 5C2. Over here 5C1. Over here three letters, so 5C3, then 5C2, then 5C1. Alright, and this comes out to be 10. This becomes also 10. This 5, this 10, this 10, and this 5. If you add all them up, the total comes out to be 50, right? Which is your final answer. Okay, it's always to write down the scenarios and add them all. That makes this so much easier. So now we come to the real question. This is the question that students actually struggle in. All right, so find the number of ways in which the 9 letters in the word crocodile can be divided into 3 groups. Whenever you see the word divided into 3 groups, that means it has to be combination. All right, each containing 3 letters. Okay, so there are total 9 letters and they're gonna be divided into 3 groups, right? So let's just divide this into 3 separate groups. Let's say one group is here. This is the second group. This is the third group. But since we're gonna be considering all the possibilities, this is gonna be the second way. One group, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3. Okay, so let's consider this is group 1, this is group 2, this is group 3. Okay, so since in combination you actually have to consider all the identical number, all the identical letters. So even if the condition here is about C, you have to also consider O there because they're the same letters, and you cannot have double counting. So you're also gonna consider C's and O's, right? So let's say that in group 1, okay, in group 1 we have one C, and in group 2 we have another C. Okay, or we can have one C here and one C there as well. Actually, it doesn't matter which way the C's are, since arrangement doesn't matter, right? So if it doesn't matter with C, what about O? Because it does matter with O, because O's condition is not here, so it can be anywhere. So let's see, if one C is here, let's say one C has 2 O's and another C doesn't have any O. Alright, or let's consider that this C, wait, let me just write 2 C's in this. Let's consider that group 1 has one O, and group 3 has another O, and group 1 has another O, or over here group 2 has another O, or we can say that 2 O's are together in this group. Okay, so these are all the ways this can be done. The reason why I'm not changing the C's, because even if you do change the C's, it will still be the same. So the C's arrangement doesn't matter. You just have to make sure that the C's are in different groups. That's all it says, right? So after this, okay, now for group 1, the case is that you have already put the C's and the O's, right? So you cancel them out just like before. 2 C's, 2 O's. You're left with 5 letters. So out of 5, how many gaps are there? There are 3 gaps, right, in total. So 1, 2, 1, 2, 3, 1, 1, 1, 2, 3, 1, 2, 1, 2, 1, 1, 2, 1, 2, 1. So so for the first, for this I'm asking, right? So out of 5, this is already filled, so 5c2 and 2 are already gone, so left is 3 into 3c3. These are all or, right? So we're gonna plus this with, there's 2 here, so remaining will be 5c1 into 4c1 into 3c3 for the second, for this, okay? Or for the fourth, which is, there's one gap here, so 5c1 into, there's 2 now, so you subtract 5 minus 1 is 3, 3c2 into 2c2. Or for the last option, 5c2 into 3c2 into 1c1. So if you add all them up, you should get 65, which is your final answer. The mark scheme will say 80, but guys, that's a wrong mark scheme. Cambridge later upgraded it, alright? Updated it. It is 65, not 80. I repeat, it is 65. This is the correct answer, okay?